Again, welcome to our next lectures. This is lecture 11-2. Our topic is derivatives of exponential functions. Again, this is Mathematics 200 Business Calculus. And this is our topic for today, derivatives of exponential functions. So our main objective in this lecture is how to find the derivative of an exponential function. In the previous lectures, we learned about derivative of a log function. So a derivative of a y equal to e to the power x. This is called exponential function. And the reason is that the variable x is an exponent. It's an exponent. So just as base e log are most convenient, we will begin by focusing on a base e exponential also. So a graph giving y equal to e to the power x. And this is also again exponential function. We shall go through, again, this is just a review. We know the log property 1, this is in our chapter 5 of the textbook. The natural log e to the power x is equal to x. The reason why, because we know natural log, the base also is e. So log base e raised to the power x will give us x, because the e will cancel the base e will cancel the log base e also. So here we can say that the derivative of ex will also give us ex. So we will see the formula here. Derivative of y equal to ex is the same as ex also. So y equal to ex, the derivative of y also equal to ex. So this is an example given. We have y equal to 3 e to the power x plus 4x minus 11. And they say we should find the y dx. Here we can use the sum and also difference properties. But we know the first term is exponential, so we have to use exponential for our first term. So this will give us the y dx, since we say the derivative of ex is ex. So derivative of 3ex also will give it, the 3 is a constant value, the derivative of ex also is ex, so we get 3ex. We know the derivative of 4x is 4. The derivative of a constant value is 0, so derivative of 11 is 0. So here we can, in short, we can say y equal to 3 to the e to the power x plus 4x minus 11, we get 3ex plus 4. Now, next is the derivative of y equal to e to the power u. So here we use the chain rule. The chain rule, u can be a composite. So in the chain rule, y equal to e to the power u, we will still get our e to the power u. Then we have to find the derivative of u. So this will give us e to the power u multiplied by du dx, because we look for the derivative of u. So here we are applying the chain rule. So those are the two properties. Derivative of y equal to e to the power x is e to the power x. Now, derivative of e to the power u, we apply the chain rule. So the answer will be e to the power u multiplied by derivative of u. And we shall see examples. So here we have y equal to e to the power natural log x squared. Now, if we have e to the power x, we know the answer will be ex. But now the answer here will be e to the power natural log x squared times the derivative of natural log x squared. So here we get again derivative of y will give us e to the power natural log x squared times the derivative. So we know the derivative of natural log s squared will give me 1 over s squared. Then the derivatives, again, we have another chain rule again. The derivative of s squared will give me 2x. So here we get e to the power natural log s squared. Then the chain rule, derivative of natural log s squared will give me 1 over s squared times 2x, which is also another chain rule for the natural log. So finally, our answer will be 2 again, 2 over x, because we cancel 1x here. Then the natural log raised to the power, e raised to the power natural log s squared. So again, one more for this example. We have y equal to e to the power natural log s squared. This is a chain rule. So the answer will be e to the power natural log s squared times the derivative of natural log s squared. So this again will give me y equal to natural log e to the power natural log s squared will give me, again, the expression e to the power natural log s squared times the derivative of natural log s squared, which will give me 1 over s squared, which know the natural log x will give me 1 over x, so 1 over s squared. Then the chain rule, s squared will give me 2x. So here we say by using the log property 2, we can say that e to the power natural log u is the same as u. Then we can simplify for the u, which will give us 2 over s squared times s squared also. What we are saying here is that natural log x squared as exponent and the base is e. We know there's a log property saying that the log is base e, so the e can cancel the e. Again, natural log base e and exponent e, they will cancel. So this will give a s squared. So that's why we say natural log u as exponent and the base is e. Natural log is log base e, so the e will cancel the e. So it will left with u. Then here we can also say u, and we get 2 over s squared times s squared. Because again, it's natural log s will be 1 over x squared. And so our final answer will be 2 over 2x. We can cancel 1x here, then we get 2x. So the answer will be 2x. What we are trying to say, this is not the final answer. Again, this is correct answer. But we know the law property that if I have e raised to the power natural log base e, they will cancel, so it will let with s squared. So that's why we got 2 over, so everything here will give me s squared, 2 over x s squared. And that will give us, so the final answer will be 2x. Again, using the log property. So they say here we should know that if we had used this property before taking the derivative, we will still have y equal to e natural log x. If I take the property, this again, natural log is log base e. So the e raised to the power log base e will give me 1. So which means y equal to s squared. And if I find the derivative of s squared, I'll get 2x. So it's up to us. Either we apply the derivative rule on it, then later we try to use the log property to solve the equation. Or I can just apply the log property first, then I'll find the derivative. All the same, you get the answer. But I think the shortest way is to first apply the log property. So I know e raised to the power log base e will give me 1. So this means I'm looking for derivative of y equal to x squared, which will give me 2x. So we have another example here. Here we say when $100 invested at 8% compounded continuously. The amount that accrues after T years, which is called the future value, is S at T equal to 100 e raised to the power 0.08 T. So this is an exponential function. Why? Because T, which is our independent variable, is an exponent in the equation. So we have 100 e raised to the power 0.08 T. Now the question says, at what rate is the money in this account growing at the end of 1 year? So the question says, at what rate? The rate. So this means we have to find the derivative of this equation. So first thing, we find the S derivative. And by looking at it, I have a constant value. So I'll leave the 100. Now the derivative of E 0.08 T will give me E 0.08 T times the derivative of 0.08 T, which will give me 0.08. So here we get 100 e raised to the power 0.08 T times 0.08. We can do our multiplication. And finally, we get 8. 100 times 0.08, that will give me 8. Now, this is my equation now. So I can plug in any T for the time. Here, the question A said at 1 year. So I'll plug in 1 year, and that will give us 8 e to the power 0.08. Again, we can use the calculator to find e raised to the power 0.08 times 8, and that will give us 8.666. Now, so here in conclusion, we can say that the future value will be changed by $8.67 during the next year, the annual rate of change after yearly. The second one answered the rate of growth of the money at the end of 10 years. So now we have the first one is say at the end of 1 year. So we get 8.67 based on interest rate given to us. And also for 10 years, so T will be 10 years now. We do our calculations, roughly we get 17.804. So we say that after 10 years, the money will grow by $17.80. So before I continue here, this is our main topic, the derivative of exponential function. So one more, let's go. So this is our first property, derivative of y equal to e to the power x. Now, derivative of y equal to e to the power x, the answer will be e to the power x. Then we saw the example given here. So 3e to the power s, the derivative of 3e to the power s will give us the same value, 3e to the power s, because we can't use the chain rule here. If we use the chain rule, the derivative of x is 1. So 1 times any value is the same value. Then the second, we use the chain rule, derivative of y equal to e to the power e. So the property here, we get e to the power u times derivative of u. So it's like using the chain rule. So this is a very good example. Y equal to e to the power natural log x squared. Find the derivative of y. So here I can use the property by saying that e to the power u times derivative of u. So in this case, we get u will be natural log x squared. So I will get e to the power natural log s squared times the derivative of natural log s squared, which will give me 1 over s squared times 2x using the chain rule. And that's what we have here. Then by simplify it, we get 2 over x e to the power natural log x squared. Now we know natural log, the base is e. So e raised to the power log base e will give me 1. So our answer will be s squared. And that's what we have here. 2 over x times s squared. And by simplify, we get 2x. Now we said earlier that we can also use the property, the log property rule first. So since I know that e to the power natural log base e, or log natural log or log base e is 1, it means everything here is 1. So y equal to s squared. The derivative of s squared will give me 2s. So you get the same answer. So either you apply the log property first before the derivative formula, or the derivative formula before we will get the same answer. So that's the example here. And we have one more example here. So now let's go through the next step, which is finding the derivative of y equal to a to the power u. Remember previously we were using exponential, e. Now a to the power u. First we set a rule here. If y equal to a to the power x, we want to make sure a should be greater than 0, which means a shouldn't be a negative value. And also a shouldn't be 1, because 1 raised to any power will give us the same answer. So if these conditions are met, which means a is it's not 1 and also it's not a negative value, then we can say dy dx equal to, again, a to the power s, then the natural log a. So again, y equal to a to the power x is the same as a to the power x times natural log a. Now, if we are using chain rule, let's say y equal to a to the power u, the same rule again, a shouldn't be negative value and a shouldn't be a 1. Then we have the same thing, a to the power u times the derivative of u. So we have the derivative of u, then natural log a. So always we end with the natural log a. So let's see an example. We have two examples here. If y equal to 4x, we should find the dy dx. So this means our answer, the derivative of y will be 4x times natural log 4. Dy dx will give me 4 to the power x times natural log 4. The same thing applies to the second also. Y equal to b 5 to the power x squared plus x. So we have to find the derivative. This is a chain rule, so we need to find the derivative here. So first we get b 5 to the power x squared plus 2x. Then the chain rule here will give me 2x plus 1. Then the natural log of 5. So we get 5 raised to the power x squared plus x times the derivative of x squared plus x will give me 2x plus 1. And then the natural log 5 of the base. Same thing applies here. Since we have a 4 to the power s, the derivative of s is 1, so I don't need to use a chain rule. But I will get 4s times natural log 4. Here also I'll get the same value times natural log 5 times the chain rule s squared times x. So again, this will be the conclusion of our lectures 11-2. Again, this is based on the derivative of exponential functions. We saw the theory, the property, and we saw some few questions, somewhere around 3-4 questions. Again, if you have any question, feel free to send an email, or you can also reach me in the Blackboard, the course Blackboard, or when we meet in class. Again, this will be posted in the YouTube, so you can make a comment there, subscribe, or like it, or unlike it. Thank you. Bye.